All right, we're in the Helicopter Flying Handbook, Chapter 11, page 12 of 24, Dynamic Rollover. Dynamic rollover is right after ground resonance. All right. A helicopter is susceptible to lateral rolling tendency called dynamic rollover when the helicopter is in contact with the surface during takeoffs or landings. For a dynamic rollover to occur, some factor must first cause the helicopter to roll or pivot around a skid or landing gear wheel until its critical rollover angle is reached 5 to 8 degrees depending on helicopter winds and loading. Then, beyond this point, main rotor thrust continues the roll and recovery is impossible. After this angle is achieved, the cyclic does not have sufficient range of control to eliminate the thrust component and convert it to lift. If the critical rollover angle is exceeded, the helicopter rolls on its side regardless of cyclic corrections made. Dynamic rollover begins when the helicopter starts to pivot laterally around its skid or wheel. This can occur for a variety of reasons, including the failure to remove a tie-down or skid securing device, or if the skid or wheel contacts a fixed object while hovering sidewards, or if the gear is stuck in ice, soft asphalt, or mud. Dynamic rollover may also occur if you use an improper landing or takeoff technique or while performing slope operations. Whatever the cause, if the gear or skid becomes a pivot point, dynamic rollover is possible if not using the proper corrective technique. Once started, dynamic rollover cannot be stopped by application of opposite cyclic control alone. For example, the right skid contacts an object and becomes the pivot point while the helicopter starts rolling to the right. Even with full left cyclic, the main rotor thrust vector and its moment follows the aircraft as it continues rolling to the right. Quickly reducing collective pitch is the most effective way to stop dynamic rollover from developing. Dynamic rollover can occur with any type of landing gear and all types of rotor systems. It is important to remember rotor blades have a limited range of movement. If the tilt or roll of the helicopter exceeds the range 5 to 8 degrees, the cyclic can no longer command a vertical lift component, and the thrust or lift becomes a lateral force that rolls the helicopter over. When limited rotor blade movement is coupled with the fact that most of a helicopter's weight is high in airframe, another element of risk is added to an already slight unstable center of gravity. Pilots must remember that in order to remove thrust, the collective must be lowered, as this is the only recovery technique available. Critical conditions. Certain conditions reduce the critical rollover angle, thus increasing the possibility for a dynamic rollover and reducing the chance for recovery. The rate of rolling motion is also a consideration because as the roll rate increases, there is a reduction of the critical rollover angle at which recovery is still possible. Other critical conditions include operating at high gross weights with thrust lift approximately equal to the weight. Refer to Figure 11-7. The following conditions are most critical for helicopters with counterclockwise rotor rotations. The number one, the right side skid or landing wheel down, since translating tendency adds to the rollover force. Right lateral center of gravity, crosswinds from the left or left yaw inputs. All right. So forces acting on a helicopter with rigid skid on the ground. For helicopters with clockwise rotor rotation, the opposite conditions would be true. All right. So cyclic trim. When maneuvering with one skid or wheel on the ground, care must be taken to keep the helicopter's cyclic control carefully adjusted. For example, if a slow takeoff is attempted and the cyclic is not positioned and adjusted to account for a translating tendency, the critical recovery angle may be exceeded in less than 2 seconds. Controls can be maintained if the pilot maintains proper cyclic position and does not allow the helicopter's roll and pitch rates to become too great. Fly the helicopter into the air smoothly while keeping movements of pitch, roll, and yaw small. Do not allow any abrupt cycle pressures. Normal takeoffs and landings. Dynamic rollover is possible even during normal takeoffs and landings on relatively level ground. If one wheel or skid is on the ground and the lift, is approximately equal to the weight of the helicopter, if the takeoff or landing is not performed properly, a roll rate could develop around the wheel or skid that is on the ground. When taking off or landing, perform the maneuver smoothly and carefully adjust the cyclic so that no pitch or roll movement rates build up, especially the roll weight. If the bank angle starts to increase to an angle of approximately 5 to 8 degrees and full corrective cyclic does not reduce the angle, the collective should be reduced to diminish the unstable rolling condition. Excessive bank angles can also be caused by landing gear caught in a tie-down strap or a tie-down strap still attached to one side of the helicopter. Lateral loading and balance, usually outside published limits, is another contributing factor. Slope takeoffs and landings, page 13. During slope operations, excessive applications of cyclic control into the slope, together with excessive collective pitch control, can result in the downslope skid or landing wheel rising sufficiently to exceed lateral cyclic control limits, and an upslope rolling motion can occur. When performing slope takeoffs and landing maneuvers, follow the published procedures. We didn't do that one. Follow the published procedures and keep the roll rate small. Slowly raise the downslope skid or wheel to bring the helicopter level and then lift off. During the landing, first touch down on the upslope skid or wheel, then slowly lower the downslope skid or wheel using combined movements of the cyclic and collective. If the helicopter rolls approximately 5 to 8 degrees to the upslope side, decrease collective to correct the bank angle and return to level altitude, then start the landing procedures again. All right. So, use of collective. The collective is more effective in controlling the rolling motion than lateral cyclic because it reduces the main rotor thrust lift. A smooth, moderate collective reduction at a rate less than approximately full up to full down in 2 seconds may be adequate to stop the rolling motion. Take care, however, not to dump collective at the excessive high rate, as this may cause a main rotor blade to strike the fuselage. Additionally, if the helicopter is on a slope and the roll starts toward the upslope side, reducing collective too fast may create a high roll rate in the opposite direction. When the upslope skid or wheel hits the ground, the dynamics of the motion can cause the helicopter to bounce off the upslope skid or wheel, and the inertia can cause the helicopter to roll about the downslope ground contact point and over its side. Under normal conditions, the collective should not be pulled suddenly to get airborne because a large and abrupt rolling moment in the opposite direction could occur. Excessive application of collective can result in the upslope skid or wheel rising sufficiently to exceed lateral cyclic control limits. This movement may be uncontrollable. If helicopter develops a roll rate with one skid or wheel on the ground, the helicopters can roll over on its side. Precautions. To avoid dynamic rollover, always practice hovering auto rotations into the wind and be wary when the wind is gusty or greater than 10 knots. Use extreme caution when hovering close to fences, sprinklers, bushes, runway, taxi lights, tie-down cables, deck nets, or other obstacles that could catch a skid or wheel. Aircraft parked on a hot asphalt overnight might find the landing gear sunk in and stuck as the ramp cooled during the evening. Always use a 2-step liftoff. Pull in just enough collective pitch control to be light on the skids or landing wheels and feel for equilibrium, then gently lift the helicopter into the air. Hover high enough to have adequate skid or landing wheel clearance with any obstacles when practicing hovering maneuvers close to the ground, especially when practicing sideways or rearward flight. Remember that when the wind is coming from the upslope direction, less lateral cyclic control is available. Avoid tailwind conditions when conducting slope operations. Remember that less lateral cyclic control is available due to translating tendency of the tail rotor when the left skid or landing wheel is upslope. This is true for counterclockwise rotor systems. Keep in mind that the lateral cyclic requirement changes when passengers or cargoes are loaded or unloaded. Be aware that if the helicopter utilizes interconnecting fuel lines that allow fuel to automatically transfer from one side of the helicopter to the other, the gravitational flow to fuel to the downslope tank could change the center of gravity, resulting in a different amount of cyclic control application to obtain the same lateral result. Do not allow the cyclic limits to be reached. If the cyclic control limit is reached, further lowering of the collective may cause mass bumping. If this occurs, return to a hover and select a landing point with a lesser degree of slope. During a takeoff from a slope, begin the levering main rotor disc with the horizon or very slightly into the slope to ensure vertical lift and only enough lateral thrust to prevent sliding on the slope. If the upslope skid or wheel starts to leave the ground before the downslope skid or wheel, smoothly gently lower the collective and check to see if the downslope skid or wheel is caught on something. Under these conditions, vertical ascent is the only acceptable method of liftoff. Be aware that dynamic rollover can be experienced during flight operations on a floating platform if the platform is pitching, rolling while attempting to land or take off. Generally, the pilot operating on floating platforms, barges, ships, etc., observes a cycle of 7 during which the waves increase and then decrease to minimum. It is that time of minimum wave motion that the pilot needs to use for a moment of landing or takeoff on floating platforms. Pilots operating from floating platforms should also exercise great caution concerning cranes and masts, nearby boats, tugs, and nets. All right, so we'll hold off there. That is page 14 of 24. That was pretty much your cyclic trim, normal takeoffs and landings, slope takeoffs and landings, use of collective while on slopes, your precautions. Page 14 and 24. Now we're going to go into low G conditions and mass bumping. All right, see.